Hello, everyone. Thank you for joining this session. Today I'm going to give you an introduction to one of the um, open source project, which is focusing on implementing internal developer platforms. The project has been highly interested in the community in the last 2 years, and I've been following the project myself really closely. And yeah, today we are going to take a look together and we will have a hands-on session and we will see what we can do with CNOE. So I will shortly introduce myself. I am Hossein Salahi. I'm lead platform engineer. Short about myself. My journey in the cloud started a while ago. I started working on large farm of OpenStack back in the day. And later, beginning of 2016, my focus shifted heavily to cloud native technologies because it was really interesting working with containers. Back in the day, the Docker Swarm was really exciting to see how the containers are changing the whole cloud ecosystem. And in the last few years, I've been focusing on building platforms on top of hyperscalers, Azure, GCP, and AWS for our customers at Liquid Reply. Um, Short about today's session. We can take a look at agenda. So we will have a short introduction. We will recap what we know about the last few years, talking about platform engineering, talking about internal developer platforms, why the term platform engineering got coined, and what are the community efforts in that regard. It will be short. And then we will look at the core concepts of platform engineering, IDPs, and through that we will walk into more in depth into CNOE. Later, we will have a hands-on session. Together, we will set up our local machines, you will get the experience of using CNOE on your machines. And after that, we will have a bit more in-depth look at how CNOE helps us to implement IDP with single binary. Yeah, it simply said a single binary, but technically it's a one binary. It helps us to spin up all the platform capabilities and resources that we need for a cloud platform. And last but not least, we will wrap up the session and then you'll have a Q&A at the end. So first, I would like to talk about what we know all from our companies, organizations. So we have the dev teams, which are technically the developers developing these softwares, and they would like to access some infrastructure, some services managed by operation teams. So at the other side, you can see the operation teams. They are engineers. Back in the day, we used to call them DevOps engineers. Now they call themselves platform engineers. So they are the people who build these services on top of the infrastructure, on-prem or on the cloud, and they provide it for the developers. So the main thing is that developers are the consumers of the what operation teams or platform teams, they provide. I haven't came across any developer in last 10 years that could tell me, yeah, honestly, I'm interested into deploying, managing, and working with infrastructure. Technically, they say, honestly, I want to focus on develop my application. I don't want to get my hands dirty with working with any cloud provider APIs. I just need these resources. Please provide it for me. So what happens? They send a request. Usually, when I talk to our customers, I say, what happens when a developer needs specific cloud resources? They say, okay, you need to create a ticket or you need to write an email. And we know what happens. It takes time for platform team to work on these resources. Hopefully, things are automated through DevOps concept that we know from past. We have pipelines, we have Terraform code. Right now, we are using cloud native infrastructure as code tools like Crossplane to spin up the resources to create it on demand for our developers. But yeah, it doesn't work all the time, and yeah, that's technically creates lots of waiting time for developers teams. So what this caused that bringing these two teams together and let them to work together. So that's how this DevOps term got coined back in the day. But it's still, as I said, the developers, they are consumers and they don't really want to get involved in those activities. So technically, we are talking about bottlenecks. So I'm stuck because I need specific resources. I need specific services from my infrastructure team, from my ops team, and I have to wait. So this is the main problem of previous practices of DevOps. So this brought us to a new era. That's where the platform engineering term got coined. Let's look at what we know from platform engineering. So platform engineering is a set of disciplines for designing a tool chains and workflows. What are those tool chains? The tools that we know it from the past. The same concepts that we know from DevOps. So DevOps is highly focusing on automating the processes using infrastructure as code, using CI/CD pipelines to speed up, the software lifecycle management, to automate all the workflows, processes that in any company we need them to manage infrastructure and application release. So there's nothing new. We are just talking about the same concept here. But what platform engineering brings, it's the thin layer of abstraction on top of all that complexity that we know from our DevOps practices. So this thin layer, it helps the platform team to highly focus on um, creating those services, those capabilities of a platform, and just exposing it through that thin layer. Later, we will look at that layer that platform engineering is proposing. And the main the main point of platform engineering is we are trying to standardize, use templates, and use the same practices from the past, automation, that helps us to scale when the demands goes high from the developer sides. Usually the platform team struggles because they cannot satisfy all developers, and sometimes developers are coming with a specific request. I need this resource with this configuration. This is not doable. So creating templates, creating a standardized platform, this thin layer, helps us to tackle those problems. And on top of that, we need to enable developers to get those resources, to get access to the services they need in a self-service manner without intervention of the people who built it. So technically, I just want to be able to spin up the resources I need by just a simple request. The simple request can be a UI, the simple request can be an API or CLI. It depends on the preference of the developers. And last but not least, it's about how we can improve the developers' experience. It's about developers' productivity, how we can shorten the time to the market for our applications, and how we can decrease the cognitive load on the developers, because involving them in infrastructure, it's not always the best way. So yeah, I talked about just this thin layer. So this is where the platform team works on integrating different capabilities of a cloud platform. So if you look at your organizations, we have also, I'm coming from my background. I worked on-prem for a few years, so I know there are different teams in classical organizations. One team is taking care of database management, one team taking care of observability. We had developers departments, some other teams taking care of the security and network. So this thin layer helps us to bring all these efforts together under the same umbrella. So these all teams works together to help to help developers with one single goal, to help them to get access to the resources they need to focus on developing their applications. The outcome of this platform engineering best practices, we just saw it. It's called internal developer platforms. So technically, an internal developer platform, or IDP, is just a set of tools and services that are glued together, and they are trying to improve and standardize the software development process. What does it mean? It means that I'm creating this platform with one goal, that I can help my developers to focus on what they are supposed to focus on, developing the software without uh, being blocked by any engineers that they are working on providing the services they need. So let's look at the core elements of such a platform. So we know it from our experience working with cloud platforms. So also part of an IDP is, we need to define the scope. So in terms of what are the accesses that are allowed for each user. So we need to define, I would call it the least privilege concept. So you should take control of this topic since the beginning. We are talking about versioning. We are technically talking about Git. So a central version management system that we are storing our our manifest, our code, our infrastructure as code, and also we need a secret management team. I'm talking about key management systems on cloud providers, or tools like HashiCorp Vault. We need infrastructure orchestration tools like Terraform or Crossplane in this case to automate spinning and provisioning our services and our resources. We are using CI/CD pipelines to automate the process. We need commodities services such as DNS. We need Kubernetes clusters, and etc., etc. And of course, as a core feature of an IDP, which comes from platform engineering, we need to make it self-service. We need to make it easily consumable for the end user on demand. And also, we know, and we are working with the continuous deployment tools. GitOps is heavily used these days by all the organization to focusing on continuous deployment. Argo CD Flux is also part of an IDP. And putting the guardrails since the beginning is really important. Using tools like Kyverno to define the guardrails since the beginning is really important. So this is also the main focus of IDP, because IDP wants to set them as a baseline, so that when you're onboarding your developers on IDP, so they will get exactly the accesses, the privileges they need. And we know it from the past, giving cluster admin access to developers to a Kubernetes cluster isn't always the best case, and this can cause a chaos. Thanks to the community, there are some reference architectures for an IDP. So this is one of them. So at the lower part, you can see the area that is really interesting for platform engineers. It's technically focusing on the capabilities that the IDP requires. So we are talking about CI pipelines. We are talking about services like OCI registries like Harbor or JFrog. We are talking about platform orchestrators like Cratix. We are talking about CD tools like Argo CD, and on the other hand, we are talking about the cloud resources that our applications most of the time need as dependencies. At the upper part, we have the area that is mostly utilized by developers. It's the area that they are on the move, using an IDE, interacting with dev portals such as Backstage, storing their code, their manifest, their Helm charts, all the packages in Git versioning system like GitHub or GitLab in this case, and of course using Terraform or Crossplane. So as you can see, the Terraform is at the and or Crossplane they are at the upper part because it can be an interface between these two areas. For example, you can use Crossplane or Terraform automated pipeline as a self-service. We cannot talk about platform without talking about observability. So you are familiar with the observability stacks from the open source community, like Prometheus or the metric shippers or log shippers, like Hotel, like FluentBit. Talking about the container networking interface such as Cilium or other providers, or talking about security solutions like HashiCorp Vault or manage KMS by the cloud providers. So with all the technologies that you can see in the reference architecture, we can create an IDP. So after focusing on creating the reference architecture, few community groups, they started working on the reference implementations. So how we can bring these technologies together and utilize it to build a real IDP. So here are few of the projects that I've came across in the last few years. CNOE is the project that today we are going to talk about. We have Crato. I've been following them for a while. Cratix is one of the interesting projects. Technically, it's a framework that you can really abstract both your infrastructure and application deployment by using Cratix, and can be nicely integrated with Backstage. And on the other hand, we have kubevela. But today, as I said, our focus is on CNOE. It is a open source project that has been active for the last few years. What is CNOE? So the name, I think it's self descriptive. So it's coming from cloud native. So we are talking about the same concept of using Kubernetes API to build a platform. So CNOE exploits the same concept. So CNOE is an IDP distribution. So technically, it's a single binary. You will see it in short that technically it's one single binary that helps us to just spin up an IDP in a few minutes. So technically, it just brings some best practice CNCF technologies. So the tools that we know all across the CNCF landscape, it's puts them together, and through that we can create a full-blown IDP. So let's look at the technology stack of CNOE. So at the left side, we are looking at the resources that we know from our own environments. So we are talking about some YAML files, some Helm charts, some Helm templates. We are talking about some code repositories, infrastructure as code, such as Terraform, Pulumi, etc. We have some configuration artifacts lying in OCI registries, or some secrets that we are stored in our KMS systems. And on the other hand, we have the operation part, which the platform engineering team is focusing on. So at the bottom, we are talking about the infrastructure, compute, storage, network. On top of that, we are utilizing the secret management system, which is our KMS. And we are using the same best practices that we know from DevOps and from platform engineering. So automation using infrastructure as code, using the continuous delivery, GitOps, and using other concept, for service discovery or workflow acquisition. And of course, you need to manage, identity and access. You need an EIM tool to manage the accesses across, your platform. And as I said, at the beginning, the main focus is that how we can expose what we have built internally to the end user, which uh, is the area that you can see is the dev portal. So one of the widely known solutions in the open source community is Backstage. So how we expose those services, those capabilities that we have built internally via a dev portal. So here we have an example of how CNOE stack can look like. This is, I would say, um, a reference implementation from CNOE. So you can see at the left side what exactly we talked about. So you have a bunch of YAML file, Helm charts, infrastructure as code, uh, container images, some secret references, and they are stored in different places. There, for example, so in this case it's stored in GitHub. So we have ECR as our OCI registry. Secrets are referenced, in Vault, or we are using external secret operator to fetch those secrets, from the our KMS systems. And at the right side, you can see that, the tools that are representing, our stack. So we are talking about Terraform, Crossplane for managing the infrastructure. Backstage, we are using Red Hat Keycloak to manage the identity and access management. Of course, you can integrate it with the other solutions such as Azure Entra and a bunch of other solution or tools that we know from our daily job, Argo CD, Flux for GitHubs, Argo workflows that we can use to run our CI pipelines inside Kubernetes. That is as a core, it's a core part of CNOE that we will take a deeper look later in our hands-on session. So I was really excited that I saw that the New York Times they started. I mean, they've been using CNOE internally. So this is how their architecture looks like. As using CNOE. So you can see that, they are spinning up the whole stack, as I mentioned. Later, we will do a deep dive. So the single binary that spins up whole CNOE stack is called IDPBuilder. So you just need to download this binary. And with this single binary, you can install whole your stack. So it will just fetch some core packages. Technically, they are Argo CD applications. So at the end of the day, they are just some YAML file. So IDPBuilder just spins up a kind cluster, installs Argo CD. Argo CD is a reference to a Git repo. It fetches all the packages required for the stack. So, for example, it will deploy a self-hosted Git versioning system called Gittee. And yeah, I mean, this is technically what New York Times has done. This is, I mean, this just small example can be enough for lots of use cases in our organizations. Yeah, a majority of cases I'm seeing, people are just asking, yeah, I have Kubernetes. I just would like, to um, use Argo CD to deploy my application. So this can be a really nice place to start. Um, so here we will switch to quickly to the Git repo that I've provided for this workshop. I have put the link here. We can just scan or just type the URL, in your browser, and yeah, then you can access to the Git repo. So I have provided a Git repo. I just need to reshare my session. Just a second. Oh, yeah, this is the repo. I hope everyone can access this repo, is reachable for everyone. So after accessing this repository, you can just jump into the folder that includes the documentation parts, for the Kuno workshop. So I'm not going to really deep dive into the whole intro part because I just already gave you kind of insight into what Canoe does and what it's capable of. The documentation is really comprehensive, so you can really go to the depths of it in your free time. So I will just go through the most interesting part for us. So yeah, as I said, the CNOE project is really highly focusing on how we can spin up an IDP in short time by using the really widely used CNCF technologies, CNCF projects. That's the main focus. And independent, where are you running? Where are you deploying your Canoe stack? It can be deployed on your local machine. So in my case, for the workshop, I'm just going to deploy the Canoe stack on my Kind cluster locally on my Mac. But you have also the opportunity to deploy it on any other managed Kubernetes services such as JKE, EKS, or AKS. So yeah, in this case, you just need give access to the cluster by yourself. Um, so okay, so there we go. Um, so we need as I mentioned, the first thing we need to check on our systems, we need to ensure that we have a running container runtime. So if you are macOS based, I mean, in my case, I'm using Podman. So you can adopt for Podman desktop or Docker desktop on your local Mac, or if you are Windows based, I think Docker desktop would be an obvious choice. Or if you are using Linux, you can just install Docker or Podman in a native way, so that it's quite straightforward. I would just like to check if everyone has access to the Git repository. I will just check. Okay, thank you guys. Thank you. Perfect. Perfect. Um, Okay, so I hope that you guys have fun of the runtimes on your local machine. So either Docker or Podman or Finch. Lately, I've been using Colima, to be honest. It's really easier for me to use Colima natively on Mac. But yeah, as I said, it's up to you. So for a Mac setup, I would suggest to just create I mean Macs with silicon chips just to spin up a Podman machine with at least two CPUs and 8 GB RAM. Yeah, on native systems like Linux, you don't need it. You just can skip the Podman machine part. We need to start the Podman machine as root. So Podman machine needs to access our host machines because that's Canoe stack. That's how Canoe stack is exposes the services. So we need to run it in a root mode so that we can smoothly expose the services that we will deploy via Canoe. And finally, you can just uh, start the machine, and then you can verify if you have started the machine. So when you have the container runtime running and ready, so it's just a simple command. So independent uh, where are you based on Linux or Windows or um, Mac. So this single command, will install the IDPBuilder binary. I'm just checking the That looks good. So yeah, this with a single command, you can install the binary, and after successful installation, you can just check for if the binary is being installed. It's available on your machine, so just you can check it. So I have a later version of the IDPBuilder. So locally, I have I think version 0.9. So yeah, if you download the latest one, so you should see a later version. So yeah, there are alternative ways you can if you yeah, technically I wouldn't trust any shell script to run on my machine locally. So you can inspect it, or if you just want to do it yourself, you can just yeah, download it by yourself. So this is the other way. Um, so after we have the IDP builder, before I would go to to really working with IDP builder to deploy the CNOE stack. I would like to take a look, how the the CNOEs, I mean how the whole technology work. I mean how CNOE um, works. So as I said, we are still talking about the same way of deployment. We are using declarative semantics. So we are using the Kubernetes API extension, which is nothing new to you guys. It's custom resource definition, and that's how CNOE is deploying its resources on top of Kubernetes. So they have the folks from CNOE project. They have written a bunch of custom resource definitions to be able to interact with Kubernetes API and deploy the resources they need on Kubernetes. And of course, we need to opt for automation as one of the best practices we know from the past. So that's why in this case we are opting for GitOps, and we are using Argo CD that will automate the whole process of deploying components and the lifecycle management of applications. Yeah, I mean technically we have the flexibility to use any tools or any technology that we want in CNOE. So you can just simply deploy a Helm chart. You can use Terraform to deploy your infrastructure by CNOE, or you can just bring your own Kubernetes manifest. In a short, you will see how we can integrate, all of them. So as I mentioned earlier, so everything is still the same. Um, Declarative semantics. We are still using the same concept. So these are the examples of the custom resource that the CNOE uses, in the stack. So um, uh, this is an example that I've put here. So take when you look at one of those custom resources, you can see it. Yeah, that it's technically it's a Git repository. So as I mentioned, we will see it shortly. We are using a self-hosted Git versioning system called Git. Git also offers an OCI registry, so you can also store your container images in this case. That's how CNOE is able to create an instance of Git. So technically, it's just a wrapper which will at the end it will be translated into Argo CD application, and inside this Argo CD application, it's just pointing to a community Helm chart which installs Git for us. And how you expose it, you can also configure it by using this custom resource. That's where the power of CNOE comes from. I would like to ask about the state of you guys. So are you able to install the IDP builder binary on your local machines? Perfect. Perfect. Guys, please give me thumbs up so that I can proceed. Um, so if you look at how the the GNU uh, manages and deploys its stack. So basically, it just uses self-signed certificates. So yeah, if you want to bring your own certificate, I of course you can. You have the possibility to bring your own good certificates. And you can, yeah, use it, to expose your services if you are going to run, workload on your environments in your company. Of course, I would suggest to use the the valid certificates from your providers. What is really interesting about Canoe, that's how, it exposes the services locally. So technically, they are using really interesting, cool kind of trick. So I can just go to the where this topic has been discussed. So this is the official documentation from Canoe project. So just some folks, yeah, probably not reachable. Um, so just to summarize it, one of the folks from the community just bought this domain and has pointed it to our look back interface. 127.0.0.1. So when you are using this domain, when you are want to expose something on your local machine, it will point to your loopback interface so that you can easily expose your service. It's really cool. I like the idea. I mean, there are other alternatives for local test me. You can find it on the internet, but Canoe uses this interesting trick. Of course, it will configure core DNS for us, so it that makes the our exposed services discoverable. You can look at the documentation from the Canoe project, and yeah, as I said, the Argo CD is our GitOps engine, which deploys our packages. These packages can be our crossplane manifest, can be our Helm charts, our application can be any tool that is, yeah, cloud native ready. So can be containerized, can be deployed on Kubernetes. So I will just show you guys. I need to reshare my session and then I will just switch to my cell session. So I hope you guys can see my screen. Please give me thumbs up. Oh, we have a question already. What if deploy Kernel on EC2 Linux instance? I need to port forward. Yes, yes, exactly. I think I have it covered. If you want to use a remote host, just give me a session. Give me a second. I think I've covered it here. So let me find it. Yeah, exactly. I can put the link in the chat. So technically, you can use a remote VM or any yeah cloud managed machine you have. You just need to port forward. So that's quite easy. So this is also the case I faced in some other workshops that some folks they wanted to use a cloud VM. So of course it's doable. Yeah, yeah. I mean, I can understand. I mean, I know that some folks they are really limited in terms of installing anything on their local machines because sometimes they are managed by the companies. So I know it can be sometimes really tricky. So I will just go back to our um sales session. So right now I have one instance of Builder. I mean, I just installed IDPBuilder stack already. So we can just take a look at the current stack. So um, I would just try to delete it and start from scratch. This is where we will get at the end. This is the reference architecture that we will get at the end. Just let me to delete the current setup, and then I will do it step by step with you guys. So if I just type this simple command, this will just spin up a kind cluster for me. So as you guys can see, this is the manifest of a kind cluster. This is not something strange or unfamiliar for you guys. So if you are using kind locally, this will just spin up a local kind cluster for us. I mean, it depends on which uh, container engine you use. If you're using Docker, Podman, so yeah, it depends on you guys. So what's happening right now? So CNOE right now, as soon as the cluster is reachable, I will just switch to another session. I hope the it's big enough, my share session, and everyone can see. Let's just check if everyone is able to see. So I will use K. I'm also kind of lazy engineer. So just for clarification, K just stands for kubectl, just the alias. So as soon as my cluster is in ready and can be used, CNOE will deploy, its the bunch of custom resource definitions. So we can just take a look. Not yet. I have a typo. So this is the first thing happens. The CNOE just drops, the custom resource just definitions that we talked about it earlier. So, and that's how it's going to bring up the whole stack. So the custom packages is just a wrapper, on top of Argo CD. So at the end, this custom packages will be translated to Argo CD, and the same for Git repositories. It will be used to bring up a Git instance by using Argo CD. And the local builds, it's used by Argo CD by IDPBuilder, to manage, the different stacks. So when your initial effort is successful, you will get such an output. So what happened here? Just yeah, the custom resource definitions got created. IDPBuilder as the initial part started to deploying the Git, some packages from the GNU project will be pushed into our Git, so as our self-hosted Git versioning system. So I will show you shortly. So how does it look like? And Argo CD is referenced to this Git repository to deploy the rest of the stack. So if I just look at my the current cluster, so as you can see that I have a namespace called Git. So that's the Git instance is deployed. It has deployed Nginx controller for us in case you want to expose something to outside, and yeah, and Argo CD, of course. So if you are familiar with Argo CD, so we have this apps concept. So if I look at the apps that are already created, so I should be able to see these three applications. So Argo CD itself, it's using as Argo CD is managing its states also. It has deployed Git and Nginx. So this is technically more or less what is all done by the IDP builder as soon as we did IDP create. So as also you can see that when the process of creation of the stack, this local stack finishes, you can see that Argo CD can be reachable via this URL, and it also gives you the username, and you can use the same command line just to get the Argo CD admin password. So if you are really interested to look at the Argo CD UI, we can just switch and we can take a look at. So of course it's self-signed certificate, no surprise. Uh, we can just look at, put it here. We have a wrong password rapidly. So let's sign in. Yeah, if you're familiar with Argo CD, this is the first view that you have when you log in. So you can see the applications that have been deployed. They are all in the synced status. They are healthy, so it means the pods are running and they are. I mean, the health checks are yeah, successful and everything looks fine. So technically, when we finish the first part, yeah, we are able to see these three applications are deployed by yeah, by the. I will just go back to our. And just let me go back to the Git repo. Okay. Um. So So if you finish this part, so you should be able also to access the Argo CD UI. I would also show you guys quickly. I will prefer to open it in a new tab instead of opening it always, in the same place. So I will show you guys where our packages or our manifests are stored. I just need to get the password for Git. I mean, the same command. It will just reveal the password instead of typing. Okay, it's Git admin. I have it's the admin is written capital, of course. I'm missing another A here. Good. So yeah, you can see I have three different repositories. So this is what the IDPBuilder has done for us. So it uses this Git as our local Git versioning system. I mean, some companies are concerned about exposing their code or their manifest into public repositories. I mean, like a public Git versioning system like GitHub. Or so this is the nice way. You can keep everything locally. Of course, you can also run GitLab instance also on Kubernetes or on your cloud environment. But this Git is really nice. At least for experimental purposes. So if I look at, for example, into um, Nginx controller definition, this is all what we know from our Kubernetes experience. So this this is what Argo CD is fetching from this Git repository. It's just going to create a namespace service account. I mean, technically, it deploys Nginx controller for us, but this is just simple YAML manifest. So depends on how you would like to deploy it. It's up to you. You can push your Helm charts here locally, or you can reference it to any OCI registry where you are keeping your Helm chart. So, can you guys just give me a thumbs up that you were able to spin it up locally? And get this simple stack running. If you have any issues with okay, nice, Vijay. If you have any issues with uh, from the beginning, I mean, with installing the container engine or with downloading the binary or spinning up the stack, so just please drop in the chat so we all can, great. So all we can take a look and we can solve it together. So this is, I think, that the first thing comes to engineering minds. So yeah, okay, I can deploy this default stack. So but what about my own packages? So let's say I have Helm chart somewhere. I have some manifest lying in some Git repositories. I would also like to deploy them in the same way by using the IDP builder. Yes, of course, we can do this in the same way, and it's quite simple. Let's imagine this is the Git repo I have. So we will do it together. So I will just um, switch to my shell session. So yeah, as we saw, the stack has been created successfully. So everything is running. So everything looks good. So I will just clone this Git repository. This repository is provided by the CNOE project. There are like some examples and some sample applications we can use for our workshop. So yeah, this is how the structure of the repo look like. So we can take a look at the basic example. So um, we have package one. So what is inside is just a simple manifest. Of course, we are doing everything with Argo CD. Yeah? So let's first take a look at Argo CD app manifest. So this is technically the simple Argo CD application manifest. It just, yeah, deploying this application. So this is something interesting they have done in CNOE. So if you use this syntax, so it means that you are pointing to your local directory. So either your manifest, the Helm charts, they are lying, in your Git repository. You can reference it same way, but if it's locally, you can use it like this. So it just, points to your local directory. So your current path. So yeah, by saying that, it means that, we have a folder here called manifest, and then ta-da. It's just a simple busybox pod. Uh, it's Alpine based pod, just, runs, the sleep command, and yeah, it just, for the demo purposes. And we can look at package two, what is inside there. So yeah, same way to configure the Argo CD. So I will just show uh the yes, please. This is the application. So we have two Argo CD applications here. So one is the famous guestbook application. So it just, you can see, instead of referencing our local path, it's referencing, yeah, the Git repo of the Argo CD examples, and this will deploy our guestbook example. And the other one is the app2 is another Argo app. It's deploying another Argo CD app. This is the basic example. Yeah, guestbook 2. So, but how we can do this? It's quite simple. Just we need to reference it by using this flag. So technically, we can just reference it to all our resources we have locally or in Git like this. So this will deploy us 3 Argo CD applications. Okay, yeah, I'm in the wrong place. So this should work now. So same way that we started using IDPBuilder to bring up our stack, same thing happening again. Just IDPBuilder is deploying those Argo CD application the same manner, we do kubectl apply. Nothing fancy, nothing different. It just, it's the binary, it's a wrapper, can do not can do more than kubectl apply. It's yeah. So yeah, we can see that it's the deployment was successful. So this means that we can just take a look at here and just check for our Argo CD applications in Argo CD namespace. So we can see that the guestbook, both of the guestbook's applications are deployed and they're healthy. So Argo fetched that manifest, deployed it, and the containers are running. So same for the test application. So it means if I just look at my default namespace, I should be able to see nothing. Of course, don't deploy anything in default namespace. That's a bad practice. So yeah, we have one for my applications. So still nothing there. Let's look at guestbooks. Yeah, guestbook is running. Number 2 is also running. Let me look at why my application didn't run. Yeah, there's deployment, no? Okay, this is where we can go quickly to Argo UI. I mean, of course, we can do this also via CLI, but we can also quickly take a look at Argo UI to see what went wrong. So I cannot see the VisiBugs. Where did you deploy it? In my app. Strange. Okay. Good. So technically, this is the first part of our experience with GNU and how we can use the the IDP builder to bring up the local stack. So yeah, this is yeah, you know it from how we want to expose the service, by using ingress controller. So this is a sample, ingress object, and then yeah, this is how you point it to your host name, and that's the rest of the magic is done by the ingress controller, and how crew tunnels, your exposed service into your local machine, and you can access it via your browser. So the next step is that we are going to deploy the reference architecture. So we can quickly take a look at the reference architecture. So as we talked earlier, two should have access. I see that there is one extra slash there. I think that's the problem. Still, and So we can directly go to the reference implementation. It should be ref X. The ref implementation, yeah. So nothing has changed here. I mean, but now we are looking at, how we can deploy whole this stack. So to be able, to deploy our application on a cloud platform, I mean, technically talking about container or platforms like Kubernetes, you just don't need, the container platform itself. You need some poolings, some services around it. How I'm supposed to manage DNS, how I'm supposed to fetch my secrets from KMS system, how I can spin up some cloud resources at the cloud providers by like Crossplane or Terraform, how I'm supposed to expose my services by Ingress. Is my cloud provider is offering me an identity and access management tools like Azure Entra ID or AWS Incognito, or I have to opt for self-hosted um, identity and access management tools like Keycloak. So you can see this whole stack. So all the tools I mentioned that are going to be deployed as part of this reference implementation. Not only those, so it's also deploying metric servers, so we can get the basic metrics from our Kubernetes platform. It's deploying Keycloak, and on top of that, it's deploying Backstage. And shortly, before deploying this reference implementation, I will talk quickly about Backstage. So what is Backstage? So most of you are familiar with Backstage, but I will give a quick introduction. I'm just looking at the questions. We have a few questions. Instead of Git, can we use our existing GitHub? Yeah, definitely. You just need to reference it. You can definitely use your GitHub or GitLab or Bitbucket. Yeah, they are supported. Can I integrate Pulumi instead of Crossplane? Yes, you can. You can. Um, the thing is that, as far as I know, Terraform doesn't have a Kubernetes operator. So my suggestion would be, if you want to use Terraform inside Kubernetes, to use to use a CI pipeline. And I think we have their variety of choices. You can choose other uh, uh, tools from CNCF landscape that then gives you, the possibility to have, CI pipelines, inside your Kubernetes. And then, of course, Argo workflow is one of the, I would say, outstanding choices. So it's up to you. But yeah, Pulumi or Terraform, yeah, you can definitely use. I will just jump into to the next part. So, if you are familiar with Backstage, so it's a project developed by Spotify a few years ago, and it's the purpose of developing such a solution was that Backstage was trying to consolidate, integrate all the teams, or the services internally provided by different teams at Spotify into a single platform. So, and that can be easily accessible, can be easily reachable, consumable by developers. So that's where the Spotify was born. So you utilize the best practices from platform engineering to create this single point of access to self-service portals that you can utilize all the, let's say, services, or it can be, honestly, it can be not only be managed cloud services, it can be simple CI pipeline, it can be CD tools, it can be your observability dashboard, it can be your crossplane exposed via Spotify. So that's a central portal that you can access all those resources on demand in a self-service manner without waiting, for a long time, and, lost tickets, in the process. So that's how they integrated all the internal processes and um, services into through Backstage. Fun fact, I was reading the other day about the whole philosophy and background of Backstage. Um, Spotify is manages their, I mean, the number of people are managing Spotify central instance is just 5 people. So, but these 5 people, yeah, they are doing tremendous job. But what is interesting that they have a huge community around Backstage. So Backstage is not honestly an easy tool to manage. It's quite complex and it can be easily overwhelming, my experience wise. But what is interesting in this case, they have 100 teams around Backstage. They are continuously developing and maintaining the plugins. Plugins, the main, let's say, the power of Backstage. So you can bring your own plugin. Let's say I'm the observability team. I'm developing a stack based on Prometheus, Grafana, Loki, etc. And I want to be able to expose my logs, metrics, traces via this central portal. So that's where the plugins are coming into play. There are lots of plugins developed by open source community. You can just integrate it into Backstage and then you need to configure it, in your configs, and then you can utilize it. Also, you can go and develop your own plugins. So if you look at the building blocks of Backstage, so I would just highlight 3 parts. So the resources, they are mapping to real objects, can be Kubernetes objects, can be a namespace, can be a Postgres instance running on Kubernetes, or it can be a 3 bucket, or it can be a Redis instance running on cloud. The components are how we define the resources in Backstage syntax. So there are a bunch of templates that we use them so to transform the resources we would like to be created on Backstage. So Backstage technically transforms these templates into target resource. So let's say I want to deploy an Argo CD application by Backstage, which we'll see soon. This will be translated from Backstage will translate it into Backstage to Argo CD application YAML, and then it will be communicated to Kubernetes API. And the last part is API, which is also the strengths of the platform. So you can use different APIs to communicate between your components. It can be a REST API, it can be other protocols. Um, so we can now try to deploy the reference implementation. So if you have access, I mean, if you guys are so far, you can just go and deploy the reference application. I mean, the reference implementation. Um, I will just check quickly. Yeah, that's the main power of Backstage. Yeah, there's a huge community of plugins, and I think the number is still rising. So now I think I would go and just deploy the reference implementation. What you need to do, you just need to copy the command and run it on your local shell. So I will do exactly the same. You can delete the previous stack. So it's one option. So we can get rid of this, let's say, simple deployment. It's just, for demo purpose. So I would prefer to delete the previous installation and then start from scratch. So now we are ready. So same process is going to happen, creating a kind cluster. This is the manifest, and we will see soon what IDPBuilder is going to spin up for us. So I can just take a look. If the stack is coming up, yeah, the cluster is still in build. So probably, the control plane is coming up. Yeah. I can just use a watch command that can help us to track this. Yeah. On the other side, we can look at the logs. Yeah, it's deploying the first, I mean, the initial tools are deployed are including Nginx ingress, and then of course git, and then Argo CD will be spawned, and then Argo CD will take care of managing the whole applications that will be deployed step by step. This might take a while because honestly, this is a big stack. So yeah, if I just share my previous slides. So technically, we are looking at this yeah, reference implementation. So this will deploy all of these tools for us. Yeah, including yeah, Keycloak, Argo workflows. The crossplane part is another part of my documentation, so it won't be installed crossplane, but later I will show you if you would like to also integrate crossplane, it can be easily done. So, but except crossplane and Terraform, the rest will be deployed for us. I'm just switching back to my shell session. Guys, are you able to start with the new stack? Are you able to deploy it? So one concern I would have is how much resources your machines have. Yeah, I'm running this on a Mac with 32 gigabyte of RAM, so I'm not that much concerned, but it can be a bit tricky, you know, with machines with less capacity. Yeah, I agree. Yeah. It can be a bit tricky. Yeah, that's I think that the wise choice would be honestly, yeah, maybe to use a virtual machine on the cloud, and then later you can just, you know, delete it. Yeah, that. So as we can see that the Argo CD has been deployed, and then step by step it starts to spin up the other services. So, so far has deployed the external secrets. The Git has been instantiated. Ingress, I mean, as the first one. Yeah, Keycloak as our identity provider has been deployed. I mean, Keycloak is a Java-based application, so no surprise, it will take for a while because, yeah, I mean, first it's starting the Postgres as persistent um, backend for Keycloak, and then it will deploy Keycloak itself. So this will take some time, but yeah, let's see how far we can go with the deployment. Yeah, I think last time I just measured the time. I think I needed like 10 minutes to get whole stack running. Yeah, I mean, sometimes it's not just a matter of, you know, how much resource you have. Sometimes it's just slow. So as it's waiting for us, I can go back to our documentation part. So yeah, as soon as you know everything is up and running, so you can just go and check, and this is the outcome that you know you should expect. So everything should be healthy. It means Argo CD has reconciled. all the resources should be created and synced, with Git repository, and everything looks good. So all our stack is complete. And also, you can take a look, the status of your pods running on the cluster. But we can confirm that, we had a kind cluster created by IDPBuilder. We deployed Git instance. We deployed our Ingress controller, Argo CD as GitOps engine, Argo workflows to take care of our CI pipelines and automate our pipelines on Kubernetes, Backstage as portal or UI for self-service cases, external secrets, to manage our secrets lifecycle in Kubernetes, to fetch it from our key management systems. And yeah, this is one of the demos that I would like to do for you guys, that you can see how we can just, spin up, and you can we can use Spark operator just to run and a Spark job. So basically, it's just a simple CI job running some analytics, inside the container. So I will just check for the status. Okay. We can go back to the shell session to see what's the status. So the kick lock is running. I think the last piece would be Backstage. If Backstage comes up, I think we can quickly show a use case with Backstage. I hope it will just happen. What happens sometimes, if you're familiar, with Argo CD application, so you can give an order how the applications should be installed by Argo CD. It's called SyncWave. So the GNU project uses the SyncWaves, but sometimes I can see that some of the applications they are hanging a bit, and I can see that the Backstage is one of them. So I would like just to go to Argo CD UI and trigger it manually. This is the trick that works most of the time. Not always, but most of the time. So, yeah, we know the game. So we need to get the secret of Argo CD. So get secret of the Argo CD. So the user is admin. And the password is what we fetched. I will just try to trigger this manually. Thank you. So yeah, package is a bit hanging. What I can do definitely is just to restart the deployment. Let's see what happens. Yeah, usually it hangs around this credentials coming from OIDC. So yeah, I think now we passed it, and I can do the same for Argo workflows. Yeah, probably same process is running. Yeah. It's already in the process, so it will heal itself. Simply said. Okay. Okay, so this means that our I go back to our documentation. So it means that our backstage should be soon available. Not yet, still probably spinning up. I can check the pipe again. So let's see what's happening here. Yeah, it's coming up. Let's see if it's now exposed and reachable. Okay, so as I said, we have integrated keycloak, so we don't need to put user passport here anymore. So we just need to use the keycloak as our SSO. So there is a default user password. So this is the command you can use to get the password for Keycloak user. You can change the password later if you want. In Keycloak, it's also documented there. So this is my password. And for this demo purpose, my username is user1. So this is what I can use to sign in into Backstage via Keycloak. So yeah, now we are in Backstage. So let's take a look what we have. So what is interesting for us is this template. So this is what I mentioned. Yeah, this is how Backstage translates, the its syntax into, I mean, it's templating into our target resources. So what we can do, I would try to just deploy a simple application. Of course, there are other examples here. You can go for creating AWS resources. For that case, you need Crossplane. So, or you can just create, simple Spark job. So we can go for this Spark example. Just go and give it a name. Let's call it demo. So this is the Java application that will be running inside our CI as part of our Spark job. So I will just review it and I will just create it. What's happening? It will transform it into Kubernetes syntax. It will push it into Git. So we should be able to see the same manifest in Git. Argo CD will pull it from Git, which is reference to it, and then it will be running on Kubernetes. So good is that we don't need to go to Kubernetes anymore. If we want, we can go, but we can see everything here. So we can see that Argo CD is syncing and is reconciling it on the cluster, so it's still in progress. So you just can click here, and from here you can just jump into Kubernetes and you can see what's happening. Also, you can take a look at the Spark job. It's not running still. If I click here, I will be directly go to Argo Workflows UI. So this is exactly what's happening. So the demo instance, I mean, the Spark job is trying to start, but I assume this won't start successfully because I think this Spark job needs quite big amount of resources in terms of CPU memory, and this won't be successful. But as we can see, things can be nicely exposed via Backstage as self-service. And as an end user, it can be a namespace. As the end user, it can be an application. It can be a Spark job. It can be a cluster. It can be whatever that you can consume, which is built by your platform team. I think we have a few minutes. I think like 7 minutes left for Q&A. I will just switch to our slides. So, and let me take a look at the questions. Okay, Tom, for my laptop, I'm going to have a build a Linux VM. Are there instructions for running this from Linux? Yes. So what I've tried a few months ago, so technically you can do exactly all of this, inside a Linux machine. Yes, you can do it there, but if you want to access it locally, you have just, to do port forwarding via SSH. Yes, doable. Or in the documentation of CNOE project, you can see that, you can use GitHub code spaces. But in my case, last time I tried, it failed because it didn't have all the kernel let's say libraries that I needed on that Linux machine. So that's why I decided to do it on my local machine. Is there a community or good place to ask questions? Yes, 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 of course. Just please reach out to the CNCF Slack channel. There's a page, there's a section for CNOE project, and you can always drop your questions there. Uh, could one use Azure pipelines instead of yeah, I mean, as I said, if there's API by cloud provider, it's enough. So you can integrate it nicely into your yeah, GNU stack. It's possible. So yeah, I will just go to the final slide. So technically what we saw today, it's how simple binary can helps us to bring up such a comprehensive platform in few minutes. And this is nothing new that we didn't know. I mean, there are a bunch of technologies, solutions coming from open source community that we have been seeing in the last few years, but how you glue them together, how you put them that they can enable such a platform is really important. That's the main focus of GNU has been in last years. And to use the same, declarative semantic of Kubernetes. So what we saw today, we deploy the local stack, we look at the tool chain, we look at how we can deploy simple applications, how we can bring up our own workspace, how we can experiment, how we can, yeah, um, technically work, and get our hands, on GNU stack. And we saw, how we can integrate Backstage, one of the widely used open source portals for self-service and service discovery. How Backstage can be nicely part of, the GNU stack to be consumed by developers. And I would say don't stop here. Please go to CNCF channel and then go to GNU page, GNU section, and ask your questions. There are great developers are working on this project, and they always appreciate feedback. Pull request, fixes, bug fixes, even small like documentation. I think everyone appreciates that. And yeah, I think that's more or less that's all. Everything comes from open source is really uh, yeah being my main focus in the last few years, and I think we should stick to it. And open source projects are the way, and that's how we can share our knowledge, and we can keep this good work up.